Welcome to our class where we're looking at subsets. So I'll begin by defining subsets and then we'll look at a few examples. So supposing a given two sets A and B. Supposing a given two sets A and B, when do we say that A is a subset of B? So we say that A is a subset of B if every element in A is in B. If every element contained in A is also in B, then we say that A is a subset of B. And that's what I've said, that if A and B are two sets, then A is a subset of B if all the elements in A are in B. Now in that case, then we write this and read this as A is a subset of B. Example, supposing this is set A with the elements 5, 2, 3, and 1. And this is set B with elements 1, 2, 3, 4, 5, 6, 8, and 9. Then clearly A is a subset of B because we can see that every element in A is in B. You can see that 5 is in B, 2 is also in B, 3 is also in B, and then 1 is also in B. So all the elements that A contains are contained in B, and therefore A is a subset of B. So we can write this. We can write A is a subset of B. Let's look at this other example. This is set A containing elements X, Y, and Z, and this is set B containing elements X, Y, W, and E. Let's see whether all the elements in A are in B. You can see that X is in B, Y is in B, but Z is not in B. And therefore, I've said that A is not a subset of B since element Z, which is in A, is not in B. In this case, we write this, that A is not a subset of B. Now, how do we tell the subsets in a set? Supposing you're given a set and then you're asked to list the subsets. How do we tell how many subsets are there and which are the subsets? So I've given this note 1 to guide us to tell the subsets of a set. The first thing that we must know is that the empty set is a subset of every set and is also a subset of itself. So the empty set is a subset of every set. So if you are given a set and you are asked to list the subsets, then the expectation is that the empty set is one of the subsets. The other subsets that you should be listing, if you are asked to list the subsets, is the set itself. Every set is a subset of itself. So if you're given set A is a subset of itself. And the other subsets will be the singleton sets. The singleton sets of the elements of the set. The singleton sets of the elements of the set are subsets of that set. Now the other thing you must know, that the number of subsets of a set are given by 2 raised to n, where n is the number of elements in the set. N is the number of elements in the set. So what I mean is, supposing I'm given this set A. Set A has 3 elements. So I expect that A has 2 raised to 3 subsets, which is 8 subsets. So that's how you tell the number of subsets of a set. It must be 2 raised to the number of elements in that set. let me just erase this, then we look at another definition. Definition 2, I want to define a power set of a set. Power set of a set, and I say that the power set of a set A, which we will denote as this, is just a class of all the subsets. It's a class of all the subsets of that set. Let me enlarge a bit. Let me enlarge my content a bit. Just a minute. So as I had said, the power set will just be the class of all the subsets, the class of all the subsets of a set. So what I mean is, if I'm given a set and I'm asked for the power set, the first thing I'm supposed to do is to get the subsets of that set, and then I write them. From there I can tell what the power set is. I'll show you an example. Let's look at this example 3. Example 3, a given set A that contains elements A, B, and C, and then we are asked to list all the subsets, and then 2, write the power set of set A. So that's, to list the subsets is very easy. We are supposed to know first of all that we have 8 subsets, not 3. There are 8 subsets, because the number of subsets from above we've seen that will begin by 2 raised to the number of elements, and this set has 3 elements, so this will be 8 subsets. And the first subset, we've already said that the empty set is a subset of every set, so I'm listing the empty set will be a subset. The other subset will be the set itself, A itself. Then the singleton sets will make subsets. So the singleton set A will make a subset, the singleton set B will make a subset, the singleton set C will also make a subset. And that's what you see here. I have A, B, C, singleton sets. And then I can also combine the sets, the elements. I have A and B will give us a subset, A and C will give us another subset, then B and C is another subset. So how many subsets are these? 1, 2, 3, 4, 5, 6, 7, 8 subsets. Now the other question was the power set of A, and I've said that this is the class of all the subsets. Once you have all the subsets, just putting them inside this bracket, inside a bracket like this, it means the class. So that becomes the power set. Now, so having looked at subsets, we now know what subsets are and how to list the subsets and even the power set. I want us to look at operation on sets. Operation on sets. What do you mean by operation on sets? By operation on sets, I mean the union, I mean intersection, I mean complement, difference, and symmetric difference. These are the operations I'll be looking at. The operation of sets I'll be looking at. So I'll just define them, and then we take an example. The union of two sets A and B, which we will denote as this. We read this as A union B. A union B. So this is a set that contains all the elements of set A or all the elements of set B. So what I mean is, supposing I'm given, just pick the right pen. Supposing I'm given A as ABC and B I'm given as 1, 2, 4. What is the union? So the union will be all the elements in A and all the elements in B. So would be A union B would be all the elements we are seeing in A and then all the elements we are seeing in B. But all the time we are doing this, we avoid repetition of the elements. So we should not repeat the elements. So that we should not have A appearing twice, B appearing twice and or 3 times here when you're getting the union. But we must ensure that we've listed all the elements we are seeing in A and all the elements we are seeing in B without repetition of an element. The intersection are the elements common to the two sets, and we denote it by this, A intersection B. These are the elements common to the two sets. Is the set that contains all the elements common to the two sets. Like our two sets here have no element in common, so the intersection is empty. The intersection of these two sets is empty. But supposing that I had an element, that element A was here there, so the intersection will be containing the common element here will be A. That's what I mean by intersection. The complement of a set, these are the elements of the universal set which are not in the set. So supposing I'm talking of the complement of A, the complement of A will be the elements in the universal set which are not contained in A. And we denote it by this or this. This means a complement or a complement. That's how I'll be denoting it in this course. So there are the elements in the universal set which are not in A. Then there's a difference. So when I'm talking about difference, then this means I'm looking at two sets A and B, or any two sets. So the difference between A and B, this would be the elements in A which are not in B. And similarly, the difference between A, B and A, this is the set that contains the elements which are in B but not in A. We can denote it this way, or we can also denote it as A this. This means difference. A minus B. This also means B minus A. So this is a set of elements which are in B but not in A. That's what I've said. I've said that the difference between two sets A and B is the set that contains all the elements of one set which are not in the other set. That is, for example, the set containing elements in A which are not in B will be denoted by this. So this is a set of elements in A which are not in B, or we can also denote it by that. Similarly, the set of elements which are in B but not in A will be denoted by this or this. Then we have the symmetric difference between two sets A and B. And I'll denote symmetric difference. Some books will denote it this way, others denote it that way, symmetric difference. But the two definitions here mean the same thing. This one means A union B minus A intersection B. So that means if I'm asked to get the symmetric difference, what I'm supposed to do is to get the union. and then subtract the elements in the intersection. The other way I can do it is to get the elements in A which are not in B, and then union elements in B which are not in A. So these two they agree, they are meaning the same thing. Let's look at an example. So I'm given set A and then set B and the universal set. So this universal set has elements 1, 2, 3, 4, 5, 6, 7, 8, and 9. We are asked to get the union. Remember that we are listing the elements in A, then the elements in B, and we avoid repetition of elements. So the union will be the set containing, let me list the elements in A. I have 1, I have 2, I have 3, I have 4, I have 7. So I've listed 1, I've listed 2, I've listed 3, I've listed 4 and 7. So I've not listed 6 and 8. I had not listed them. So this is the union. The set comprising of 1, 2, 3, 4, 7, 6, and 8. So the order in which you list these elements does not matter. You cannot list them. You can list them in any way. Okay, let's get the intersection. So the intersection are the elements common to the two sets. So the elements common to the two sets, let me see, 1 is common, 1 is common, 2 is also common to the two sets, 3 is not, 4 is common, 6, 7 is not. So this is the intersection. The set comprising of 1, 2, and 4. What about B complement? B complement, this will be the set comprising of elements which are in the universal set but they are not in B. So the universal set has 1 and 1 is in 2, 1 is in B, 2 is also in B, 3 is not in B, 4 is in B, 5 is not in B, 6 is in B, 7 is not, 8 is in B, 9 is not. So this is a complement of B complement. So D, we want A complement. This should be the elements in the universal set which are not in A. So let's again see. A has 1, 2, 3, 4, but it's lacking 5, it's lacking 6, but it has 7. So you can see 7 is there. There is no 8 and there is no 9. So this is our A complement. Now, so we're supposed to get A minus B. A minus B. These are the elements in A which are not in B. Elements in A which are not in B. So A minus B is the set comprising of A minus B, elements in A which are not in B. A1 is in A and is also in B. 2 is in A, is also in B. 3 is not in B. 4 is in A, is also in B. but 7 is not in B. So this is A minus B. This is the difference between A and B. What about the difference between B and A? The elements in B which are not in A. I can see 6 and 8. 6 and 8 are in B but not in A. So they make the difference between B and A. Finally, let's look at the symmetric difference. Symmetric difference. And we have two formulas. We want to see if the two formulas agree. So the symmetric difference, we've said, is the union of A and B minus the intersection. The union is here. The union had 1, 2, 3. This was a 3, 4, 7, 6, and 8. The intersection had 1, 2, and 4. So just subtract 1, 2, and 4. 1, 2, and 4. We are left with 3, 7, 3, 7, 6, and 8. That is if I use this formula. If I use the formula A union B minus A intersection B. We already have the intersection 1, 2, 4, and we have the union 1, 2, 3, 4, 7, 6, and 8. So I subtract these two, I get this. What about if I use this other formula? A minus B union B minus A. What is A minus B? A minus B is here, and B minus A is here. So the union of these two will give us this. So again, we can see that these two formulas agree. So you can use any formula, any of these two formulas, while getting the symmetric difference. So next time we look at other properties, other topics and subtopics about concerning sets. Today we're just looking at subsets and operational sets. Thank you.